In this question, it is given that A and B are 2 points on a uniform metal ring, whose center is O. The angle AOB is theta. A and B are maintained at two different constant temperatures. When theta is equal to 180 degree, the rate of total heat flow from A to B is 2 watt. When theta is equal to 90, this rate will be. So over here, we can just consider it like this. Assume that there is a conductor which is in circular shape, and initially we are providing some potential difference across these 2 points. Take it as point A over here, point O is over here, and point B is over here. So we are providing potential difference or the difference in temperature across point A and B. So what will happen, some amount of heat flow is happening through this path and some amount of heat flow is happening through this path. So if you would like to find out the value of total heat flow through this, so just for calculation purpose, it is better to consider it as like the resistance of upper part is nothing but R, or if you are just considering the resistance of total this conductor or in circular shape is equal to R. So half of this portion is over here and half of this portion is over here. So it is like two resistors which are connected in parallel. So we can just redraw this arrangement like this. There is a resistor of resistance, let's say if total resistance is R, this we can take it as R by 2, and the remaining portion R by 2 is over here, and we can say that these two resistors are connected in parallel. So as they are connected in parallel, we can consider that its equivalent resistance is equal to nothing but R divided by 4. So we are considering that total resistance of the circuit is equal to, or this ring is equal to R. Now we are dividing this one into two equal parts. So this part is having a resistance R by 2, and this part is also having a resistance of R by 2. And as they are connected in parallel, we are just finding out the value of equivalent resistance, which is equal to R divided by 4. Now in this question, it is given that the total rate of heat flow from A to B, if this theta is equal to nothing but 180, if theta is equal to nothing but 90 degree. So we can just draw the condition over here. If theta is equal to 90 degree, then situation will be something like this. Let's say this is nothing but our point A and this is nothing but our point B, so that this angle becomes equal to 90 degree. Now we can say that if the total resistance is R, as we know that resistance is directly proportional to length, because we'll write this R is equal to nothing but L divided by Ka. So if the total resistance is R, then this portion is having our length, that is 1/4 of total length. So we can write this as R by 4, and this having 3R divided by 4. So we can find out, and these two resistors are connected in parallel between point A and B. So over here we can just consider this combination is similar to a resistor of resistance R by 4 is over here, and another resistor of resistance which we can take it as nothing but 3R by 4 is over here, and some amount of heat is flowing through this combination. So we can find out what about the value of equivalent resistance of this combination. We can write 1 by R equivalent is equal 1 divided by R1, which we can take it as R divided by 4 plus 1 divided by 3R divided by 4. So we can write the value of 1 by R equivalent is equal to 4 divided by R plus 4 divided by 3R. So if we are taking this 3R as nothing but LCM, we can take it as nothing but 12 plus 4, which is 16 divided by 3R is the value of R equivalent. So we can write the value of R equivalent is equal to nothing but 3R divided by 16. Now we can identify what about the value of rate of flow of heat energy. So we can write the value of rate of flow of heat energy dQ by dt is equal to difference in temperature divided by resistance, as difference in temperature is constant. In both the situations, you can write this dQ by dt is directly inversely proportional to the value of resistance. So you can write the value of Q, rate of flow of heat energy, in the second situation by rate of flow of heat energy in the first situation is equal to we can take it as nothing but R1 divided by R2. So Rm is to find out the value of Q2, which we can take it as Q1 into R1 divided by R2. According to the question, this Q1 is given as nothing but 2 watt, but there is a small correction in this question. So this is not 2 watt, this is basically 1.2 watt. So we need to change it as 2 watt to 1.2 watt. Then only we'll get the correct answer. So there is a small correction. So we can take it as this Q is equal to 1.2 into resistance R1. So in the first situation, resistance was R divided by 4, and so resistance in second situation, which is equal to 3R divided by 16. So you can observe that this R and this R get cancelled. Thus we can rearrange this one something like this. This is equal to 1.2 divided by 4 into 16 divided by 3. So we can cancel this 4 and 16, we'll get as it is 4, and this 3 and this 1.2, that is 0.4. 0.4 into 4, we can take it as 1.6.